Hi everyone. Okay, so let's go over the exercises and problems that I assigned for these units. So exercises for 12.1, question 3. A 20-year annuity is purchased for $400,000. Okay, so we purchased an annuity for $400,000. So we had to give the company $400,000, and now they're going to make payments back to us. Okay. So what payment will it deliver at the end of each quarter if the undistributed funds earned? So after a payment's made to us, whatever's left in that annuity, of course, is going to continue to earn interest. Okay. So A is 4, B is 5, C is 6, D is 7. Okay, so let's have a look. So we know that the purchase value, it is purchase value, but present value of 400,000. We know that the term is 20 years. And then for A, we know that our IY is 4, and we know that our N is the 20 years multiplied by the quarterly, which gives us 80. Okay. So again, you can use the formula to calculate, or you can put this into your financial calculator. So we have 4 IY, then we have to go to the second PY to be able to put in 4, and then make sure that both your PY and your CY are 4, and then enter, and then you need to come out of the second level again. So you want second, and then the CPT button, which will take you to the quit. Then we want 80N. Then for the present value, again, it's money going out of our pocket to a company that's going to end up giving us payments back. So that's 400,000 negative for the present value. So you need your 400,000, hit the plus or minus button, and then it'll have minus 400,000 on your screen, and then PV. At the end of all this, it's going to be 0, so 0 future value. And now we need to compute payments. So how much will we receive quarterly based on this information? And for A, if it's only earning 4%. So we will receive payments of $7,287.54 quarterly. Okay, so now you can see here as well, in each case, also calculate the total earnings distributed over the life of the annuity. Okay, so what you want to do, we know that there's going to be 80 payments of the $7,287.54. So you want to add that up or multiply that together. Then you want to subtract off the original 400,000 to find out how much over the life of the annuity, how much interest was accumulated. So we know it's 183,003 and 20 cents. So let's have a look at B. So the only thing that's going to change is your IY. So you can skip putting all the other amounts in, just hit 5 IY, compute payment. And so therefore, if the 400,000 over the life of the annuity is 20 years, you're going to have $7,938.61 being paid to you quarterly. So again, we want to find out how much the investment of the 400,000 has earned. So you know that you received 80 payments of $79.38.61. So multiply that out. Subtract off the original 400,000 that you invested, and your earnings on this investment was $235,088.80. For C, we've got payments. Again, put it in your calculator. We've got payments of $86,1933 for earnings of this investment of $2,890 289,546.40. And if it's earning interest of 7%, we're going to get payments of $9,328.37. And again, the amount that the investment earned, we're getting those payments quarterly, so multiply that by 80, subtract off your original investment of $400,000, and then it's showing you that this investment over its life earned $346,269.60. Let me know if you have any questions about that, okay? All right. So number 7, what monthly payment is required to pay off a $50,000 loan in 7 years if the interest rate on the loan is 7.5% compounded annually, semi-annually, quarterly, and monthly? Okay. So as you can see here, there's monthly payments, but then we want to change the CY, the compounding per year. And that's A, annually, B, semi-annual, C, quarterly, and D, monthly. So if we figure it out where it's compounded once a year, you're going to have payments of $760.86 once you put all the other information in. If we change the CY to semi-annual, then it's going to, and again, the only thing you have to change putting that into your financial calculator is the CY, okay? So you're going to have the compute payments, you're going to get $764.09. So you can see it has increased a little bit with the compounding going from annual to semi-annual. And then for C, we get a payment of $765.77. And for D, if it's being compounded monthly, we get payment of $766.91. Let me know if you have any questions about those. And number 11, Karen obtained a $20,000 loan at 4% compounded semi-annually. Okay. What monthly payments, so you can see that this again is an ordinary general annuity. It's not a simple annuity because the compounding period and the payments are not the same. In this case, it's being compounded semi-annual and the payments are monthly. So you have to go in and change the payments per year and the compounding per year. So given this information, you're going to compute payment, and it's going to give you an answer of $257.28. We're going to multiply that. So what monthly payment will repay the loan in 7.5 years? So your answer is there, $257.28. Now, how much interest will Karen pay over the life of the loan? That's always a good thing to know, okay? So the loan amount at the beginning was $20,000. She made payments of $257.28 90 times. So multiply 90 by the $257.28, subtract off the original loan of $20, and that gives you $3,155.20, and that is how much interest Karen paid over the life of the loan. Okay. So exercises 12.2, problems 1 and 9. Semi-annual payments of $38.74.48 are made on a $50,000 loan. Okay, so $50,000 loan, we know that is your present value. At 6.5% compounded semi-annually. So how long will it take to pay off the loan? Okay, so we know the present value of the loan is $50,000. We know how much the payments are. We know what our IY, our interest rate is. It's 6.5. And we know that the future value is going to be 0 because it's going to be paid off. Okay, so let's put the information in. We have 6.5 IY. We have payments per year of 2. Okay, and our compounding is 2 as well. We have 50,000 present value. Okay, so that's 50,000 coming into us because we borrowed it. So to make our payments, we know that it's $38.74 and 48 cents. You have to turn that into a negative, so you want your plus minus button, and then hit payment, 0, future value, and then compute N. Okay, and your answer is 17. So it says, how long will it take to pay off the loan? So 17 divided by 2, right, because it's semi-annual. That gives us 8.5 years, or 8 years and 6 months. Okay, so let's look at problem 9. How long will it take an RRSP to grow to 700,000? If it takes in month-end contributions of 1,000 and it earns your 4% compounded monthly, so they're both the same, your PY and your CY. Okay, so we know our interest rates are different. So let's have a look at the solution. So under the first scenario, we have an interest rate of 4. We put our information in our calculator and we get the number of payments of 361.79. Remember, you must round up to make sure that we get exactly, if not more, than what we're looking for. So it's 362 contributions, and that's months. So you can divide that by 12 to figure out how many years and months, and it'll take 30 years and 2 months to grow. For B, we change it to 6 IY. That gives us an answer of 302 months, or 25 years and 2 months. And then for C, we have 8 IY, and D, we have 9 IY. 8 IY works out to 262 months, or 21 years and 10 months. For 9%, we require 246 months to get it paid, and for our RRSP to grow to 700,000, or 20 years and 6 months. Okay, so remember to convert the months over to the number of years. Okay, so that is it for chapter 12. We will move on to chapter 13 in the next video. So again, let me know if you have any questions.